Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 8 minus 625 is equals to 0, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first we will rewrite this equation as, here you have n to the power of 8, and we will write this n to the power of 8 as n to the power of 4 and its whole squared, minus here you have 625, and we will know that 625 be the square of 25, and this whole equation is equals to 0. And now in the next step we will use here the nice square identity, and you know about this one. If we have a squared minus b squared, it is equals to a minus b times of a plus b. So now we will use here this nice formula. So the above equation will be written in the form of, here we have n to the power of 4 minus 25 times of n to the power of 4 plus 25, and this whole equation is equals to 0. And now we again rewrite this equation as, if you focus on the first factor, here we have n to the power 4 minus 25, and we can rewrite this factor as n squared and its whole squared, minus we have 25 and we write it as 5 squared times of n to the power of 4 plus 25, and this whole equation is equals to 0. And now in the next step we will again use here this nice identity here, so that this expression will becomes in the form of n squared minus 5 times of n squared plus 5 times of n to the power of 4 plus 25, and this whole equation is equals to 0. So here we have three cases. The first case is, we take n square minus 5 is equals to 0, and the second case is, we take n square plus 5 is equals to 0, and the third case is, we take n to the power of 4 plus 25 is equals to 0. So here we have these three cases. So now we can solve these three cases in order to find the all eighth root of the given equation. So first we solve this one. I can name this as equation number 1, this as equation number 2, and this as equation number 3. So now I can solve these three equations one by one. So first I can solve the equation number 1. So equation number 1 implies that here you have n squared minus 5 is equal to 0. So we move this minus 5 in the right hand side, and you will get n squared is equals to 5. So here we take the square root on both of the sides, and here you see that these 2 and square root are gone, and you will get here n is equals to plus minus square root of 5. So these are the first two real roots of the given equation. So now we move towards the equation number 2. So now this equation number 2 implies that we move this plus 5 in the right hand side, and you will get here n squared is equals to minus 5, and again we take the square root on both of the sides in order to remove this square. So you see that these 2 and square are gone, and here you get n is equals to plus minus, here you have a negative sign inside the square root. So you know about this one, it is equals to iota. So we can write it as square root 5 into iota. So these are the other two roots of the given equation, and these two roots are the complex roots. So here we will find up to 4 roots, in which 2 are real and 2 are complex, and now we move toward the third case. So in third case we have n to the power of 4 plus 25 is equal to 0, and we can solve this one. So here I can write equation number 3 implies that here you have n to the power of 4 is equals to 25, plus 25 is equals to 0. So now we move this 25 in the right hand side, so that here you obtain n to the power of 4 is equals to minus 25. And now we can take the square root on both of the sides. So you will get here n squared is equals to plus minus square root of minus 25. And here you see that the square root of minus 25 is equals to plus minus 5. And here again you see that we have negative sign under the square root, so it will be equals to iota. So here you have two cases. The first case is we take n squared is equals to plus 5 iota. Here we have n squared is equals to plus 5 iota, and n squared is equals to minus 5 iota. So here we again remove the square on both of the sides, so we can take the square root on both of the sides, and you will get here these two and square root are gone, and here you get n is equals to, here you have plus minus, we can just write it as square root of 5 into, here you have iota, and we can just write this as iota power 1 over 2. And similarly we move toward the second part, and here we can again take square root on both of the sides, and you will write here these two are gone, and you get n is equals to, here again you focus on this term, and you see that negative sign again appear under the square root, so we can write it as 5 times of iota square root into iota. And here you see that when you can separate this square root, then you will get here square root 5 into iota power 1 over 2 times of iota, and we see that bases are same, so we can finally write it as iota power 3 over 2. So these are the other two. Here we can write this plus minus sign. So these are the other two complex roots of the given equation, and these are the two. So here we have 8 roots of the given equation. So these 6 roots are complex roots, these 2 roots are complex, and we can find above the other 2 complex roots are plus minus square root 5 iota. So these two are complex roots, and n is equals to plus minus square root of 5. So these two are the real roots. So these two 4 and these two 6 are complex, and these two are real roots. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.